What does it really mean for an AI system to be trustworthy, not just accurate? In this episode, we explore three cutting-edge benchmarks that push models beyond surface performance. One tests whether AI can actually do science. Another asks whether medical VLMs can refuse when visual evidence is broken. And a third demands transparent, citation-backed recommendations. Together, these papers reveal a bigger story about the gap between fluent answers, grounded reasoning, and real-world accountability. Let's explore the first paper, MLS Bench, a holistic and rigorous assessment of AI systems on building better AI. MLS Bench introduces a benchmark for ML science rather than ML engineering. 140 executable tasks across 12 domains, including language models, robotics, optimization, reinforcement learning, systems, and trustworthy learning, each requiring an agent to modify one research-relevant component and prove that the change generalizes across at least 3 evaluation settings. Its key novelty is rigorous attribution. Editable scopes are tightly constrained to the algorithmic axis. Strong human baselines are reproduced inside the same scaffold. Parameter count caps, block scale hacking, and a baseline-anchored scoring transform maps heterogeneous metrics into a bounded comparable score. The authors also release MLS Bench Lite, a 3.0 task subset that still spans all 12 domains and costs 99.2 H 100 hours, instead of 704.7. On 15 frontier models, performance remains far below human soda. For example, on MLS Bench Lite, the best model reaches 36.1%, while the strongest human baseline is 50% plus by design, and on the full benchmark, human soda averages 38 versus 27.8 for the best agent configuration. Ablations show that engineering-style tuning is easier than genuine method invention, that removing capacity checks enables trivial wins through larger models, and that more context, more search, or more test time compute does not solve the discovery gap. The strongest failure analysis finds a bias toward recombining visible baselines rather than generating mechanisms with explicit hypotheses, indicating that the bottleneck is scientific judgment planning experiments, allocating scarce compute, and turning feedback into scalable evidence, not just proposal generation. Let's explore the second paper, MedVigil Evaluating Trustworthy Medical VLMs Under Broken Visual Evidence. MedVigil reframes medical VLM evaluation around an evidence contract. When a vision-required question is paired with a false premise, ROI masked image, negation, or knowledge-only rewrite, the model should refuse rather than issue a fluent but unsafe answer. The benchmark contains 300 clinician-authored cases drawn from VQA-RAD, Slake, ROCO, and Mimic CXR, Chexpert-derived chest X-ray prompts, expanded into 2,556 MCQ probes and 240 counterfactual triplets, with every gold answer, refusal option, ROI box, risk tier, and perturbation finalized by 4 board-certified radiologists. MedVigil scores 16 vision-capable models plus 2 text-only DeepSeek baselines using 7 exact match metrics aggregated into the harmonic mean MedVigil composite score, MCS, combining capability, risk-weighted safety, and ROI grounding. The strongest audited model is Claude Opus 4.7 with MCS 69.2, but the independent radiologist baseline reaches 83.3, leaving a 14.1-point headroom. Safety failures are substantial. GPT 4.0 posts 53% silent failure rate on trap probes and falls to MCS 44.1, while Gemini 3.1 Flashlight achieves the best ROI contrast at plus 49.5 percentage points, yet still trails the human baseline. The key novelty is that clean input accuracy does not predict trustworthy behavior under broken evidence. Models with high knowledge-only accuracy near 99% can still fail on ROI masked or false premise probes, revealing heavy language prior dependence. The paper also shows that visual grounding decays sharply under Gaussian blur, with language takeover points ranging from 16px to 64px across representative models, and that even the human baseline is not perfectly safe, with 5.8% trap silent failure rate on high-risk cases. Let's explore the third paper, Trace Tourism Recommendation with Accountable Citation Evidence. Trace introduces a tourism conversational recommendation benchmark that makes citation evidence and recovery first-class evaluation targets, not post-hoc add-ons. The dataset contains 10,000 multi-turn dialogues over a balanced Yelp knowledge base of 2,400 POIs across 8 US, cities, and 34,208 reviews, with verbatim review span citations on every recommendation, turn and explicit reject, and refine turns after user rejection. Trace evaluates 14 baselines spanning TF-IDF, dense retrieval with all, mini-LM, L6v2, itinerary planning, and GPT-5-4 mini variants such as LLM zero-shot, DST, RAG citation, and multi-review synthesis. Its key novelty is a 3-competency protocol measuring accuracy, grounding, and recovery, with 25 metrics, including the new Composite Grounding Score, CGS, which combines fuzzy grounding score, citation density, and provenance coverage, so citation-free answers cannot score well. The main result is a 3-competency gap. LLM zero-shot achieves the best close-set recall at 1 at 0.533 and rejection recovery at 0.988, but non-LLM retrievers dominate surface grounding, with dense reaching CGS 0.864 and TF-IDF reaching 0.776. However, their NLI-based entailment grounding collapses to 0.11, 0.193, revealing that verbatim citation is not semantic support. Multi-review synthesis fails sharply on grounding and recovery, scoring CGS 0.008 and recovery 0.263. Human evaluation on 90 items validates the metric design. Grounding score correlates with citation precision at Spearman Rho equals plus 0.8, while CGS and citation density correlate at plus 0.47 and plus 0.29. Trace reframes accountable tourism recommendation as the joint problem of selecting the right POI, backing it with auditable evidence, and repairing after rejection. That's a wrap on today's AI paper highlights. Thanks for watching.